You're watching a Hanford Communities Issue Briefing, highlighting important environmental cleanup issues at the U.S. Department of Energy's Hanford Site in southeastern Washington, issues affecting citizens of the Pacific Northwest and the nation. The Hanford Communities Organization was established in 1994 and is comprised of the communities surrounding the Hanford Site, forming one voice to advise the Department of Energy on important transition and cleanup issues.
The River Corridor is a 220 square mile area of land on the government's Hanford Site that borders the Columbia River, north of Richland, Washington. Equal in size to the city of Chicago, Hanford's River Corridor is bordered by roughly 50 miles of the majestic and powerful Columbia River. This river, a cornerstone of the region's economy and culture for centuries, is at once geologic, ecologic, and historic. Its abundant waters, shores, and wildlife have supported generations of Native American tribes, including the Yakima, Wanapum, Umatilla, and Nez Perce. With Lewis and Clark's Corps of Discovery expedition, the Columbia captured a nation's imagination, setting the stage for westward expansion and settlements such as the White Bluffs and Hanford townships. Today, more than 1 million people live in cities and towns downriver from the Hanford Site. The river is a driving force of modern energy, agriculture, transportation, recreation, and commerce.
I've lived on the Columbia River since I was 10 years old, and it's an integral part of our life in this area. You know, we like to have it clean, or we take our kids to boat in it, play in it, and you know, it's an important factor that we take care of what we have.
We're going to try to turn it back to the wildlife. We do a lot of fishing up in the Reach. But since I was a kid back in the 80s, my uncle took me up there. Now I take my kids up there.
And I remember going out to the N reactor a long time ago, 50 years ago, when President Kennedy came. And I was 14 years old. And that was, so it has a memory with me. So it's pretty special.
It is here, along a free-flowing stretch of the Columbia River in southeastern Washington, that plutonium was produced as part of the Manhattan Project, helping bring an end to World War II and later fueling the United States nuclear weapons stockpile during the Cold War. In total, 9 large, full-scale nuclear production reactors and hundreds of support buildings and facilities were built and operated in the River Corridor. Water was plentiful and easy to access, pumped from river to reactor, where it was used to cool the reactors, then returned to the river. These reactors produced nearly 2/3 of the nation's supply of plutonium from the 1940s to the 1980s. Hanford's 300 area, part of the River Corridor just north of Richland, Washington, was vital to that process. The 300 area was home to more than 200 research, development, and fabrication facilities that produced more than 20 million rods of uranium fuel for the reactors.
We had a war to win back in '41, and we were on a timeline, and people scoff at that, but you know, we're out here cleaning it all up and trying to get it done.
I've been out here for 37 years, right here in the 300 area the whole time. Ain't too many people that can say that, I don't think. The big difference to me would be the fact that before, you know, we were fabricating the fuel for N reactor, and so we were building building stuff up, making things happen, and now it's kind of now we're cleaning it up.
In Hanford's River Corridor alone, hundreds of buildings and soil sites and billions of gallons of groundwater were contaminated with radioactive and hazardous materials, making the River Corridor one of the country's largest environmental cleanup projects. Instead of leaving waste in place, the Department of Energy and contractors like Washington Closure Hanford are removing buildings and contamination that would threaten the Columbia River in the future. Since the mid-1990s, cleanup at Hanford has been focused on protecting the Columbia River for future generations, protecting human health and restoring groundwater. Efforts underway in the river corridor are supporting this important environmental objective. The goal is to clean up the land so that it is safe for activities such as preservation and recreation, and in limited areas, industry. In the river corridor, that goal is being achieved by moving more than 16 million tons of contaminated debris and soil away from the river. In Hanford's 100 area, all but one of its 9 nuclear reactors will be cocooned. Cocooning involves cleaning out and demolishing dozens of support facilities, as well as a good portion of the reactor itself. What's left is a single building on the desert landscape, sealed up safely for decades, until radioactivity decreases to the point that workers can dismantle the reactor cores.
A lot of the buildings that we had in the 300 area have now been leveled out and the grass is growing. The site that I was talking about at -7 that we actually came in one summer, completely dug that burial ground. It had a thorium trench in, we cleaned that all up. Now you drive by it and it's actually back to sagebrush and the level land. Here at 61810, we've seen it go from the desert landscape to the excavation that you see behind me here with all the holes. And when we leave, it's going to look like the desert again. That's going to be pretty awesome.
It's a very honorable mission to be cleaning up the groundwater and the atmosphere and the area around here and making it go back to the way it was.
Cocooning Hanford's reactors is only part of the cleanup equation in the river corridor. Moving radioactive material away from this area is critical to eliminating the risk of contaminating the Columbia River in the future. Washington Closure Hanford has removed nearly 200 buildings from the 300 area alone. From the 100 megawatt plutonium recycle test reactor, now buried at the Environmental Restoration Disposal Facility, or ERDF, to the 3 million pound vault that once stored highly contaminated waste generated from laboratories, fuel fabrication facilities, and test reactors in Hanford's 300 area.
We've just been working on the 340, we just got done with 340 ball, and the 309 PRTR. It was a long process to get those vaults out. Ran into some little bit more waste or remediation that will maybe what we figured and prolonged the job, but it was nice to see them going down the road for sure.
While many of these images represent the final and impressive stages of demolition, it is important to note that these projects are highly complex and require extensive planning. Removing contaminated equipment and materials to ready a building for demolition can take months or even years. During decades of operations at Hanford, billions of gallons of water, some of it contaminated with chemicals and radioactive material, were discharged from plutonium production facilities to several disposal sites in the soil across Hanford, including the river corridor. Washington Closure's team has successfully and efficiently removed the majority of the sources of contamination, waste sites, buildings, and burial grounds that threaten to contaminate groundwater and the Columbia River. Because of the river corridor team's successes, additional work was added to our work scope, a testimony to the team's safety performance and cleanup progress, despite the discovery of many undocumented hazards and changing conditions during cleanup. Despite the tremendous progress, challenges remain, including removing a research and development facility with highly radioactive material inside and below the 324 building, and cleaning up 2 waste sites with highly radioactive and hazardous waste, known as the 61810 and 11 burial grounds. When cleanup along the river is mostly complete, the landscape of Hanford's river corridor will be dramatically transformed, mostly barren and close to its natural state, leaving only cocooned reactors, occasional yellow pilings that mark groundwater wells, and a few slabs of concrete in areas designated for industrial use. This tremendous progress is one that river corridor workers should be proud of. Without outstanding safety performance, the amazing transformation would not have been successful. Working closely with DOE customers, state and federal regulators, nearby communities, and other stakeholders, Washington Closure and the River Corridor team are successfully preparing the 220 square mile area for a post-cleanup future, bringing Hanford's River Corridor one step closer to being available for future use.
I think the key thing is to finish on a strong note and finish where everybody can, in a safe manner, but hold their heads high and finish strong.
And as it has since the beginning, the Columbia River, in all its majesty and might, will indeed roll on, the cornerstone of the region's culture and economy for generations to come.
Good morning, I'm Dennis Falk. I'm the program manager for the Environmental Protection Agency here at Hanford. It's been my privilege to be able to work on the River Corridor cleanup since its inception. We've made a tremendous amount of progress over the years, and again, it's great to be able to hear and share some of the accomplishments that we have.
Good morning, my name's Nina Menard, and I'm a project manager with the Washington State Department of Ecology. A lot of my work has been centered in the 100N and the 100DNH area, and I would have to echo Dennis in that a tremendous amount of cleanup has been accomplished along the River Corridor.
Good morning, I'm Scott Sachs, President and Project Manager, Washington Closure Hanford. Our company came into being for the sole purpose of cleaning up the river at the Hanford Site. We came into business in 2006 and took over the River Corridor cleanup, and essentially our mission was to execute the 2015 vision. The 2015 vision was to clean up the entire river corridor of the Hanford Site, which is about 42 miles worth of river and 220 square miles of the Department of Energy site.
I'm Bob Larson with the Port of Benton, and we're really proud of Scott, of what your company has done and cleaned up the Hanford Site on the river. And but I wondered if you had one project on what in your contract that you were really proud of.
That's an interesting question, and I think I'll give you an interesting answer. The River Corridor closure is a single project. It was designed to be able to allow us to open up the work faces across the site, so that if we encounter problems, we keep efficient and we move our workforce from site to site to site. And so the one project that I would really be proud of is the whole project and the ability of our team to work with regulators and go off and attack open work faces and maintain our efficiency.
Good morning. My name is Diane Howard, and I'm also with the Port of Benton. Scott, question for you. How many employees do you currently have, and what's your plan once the contract comes to closure?
We currently have about 717 employees. We put together a people plan, and part of our success is communicating and giving as much power to our workforce as we can. So each employee for Washington Closure, including me, has an end assignment date.
So I'm Bob Thompson with the Energy Community Alliance and the City of Richland. My question is a little bit more global, and it's for both Nina and Scott to kind of take a look at it from different viewpoints. This particular contract, Washington Closure contract, seems to have been pretty efficient. And so I was wondering if that is an opinion held by ecology, and Scott, do you think it's a model nationwide, the terms of this type of contract and how it's been implemented here at the Hanford Site?
I'll go ahead and address that question first. It has been a pleasure in many respects to work with WCH and with DOE in the fact that the staff was able to work well together. At one point, as you can imagine, there's a massive amount of paperwork that documents the cleanup of all these various waste sites. At one point, the Department of Ecology participated with WCH and DOE to streamline the process. We called it a lean process, to be able to become more efficient in how the paperwork was processed and how it was documented. And that not only shortened the time frame to process all the paperwork, it also saved money by becoming more efficient.
I'll echo that, and I'll expand a little bit more. You can't go through a lean process and reduce your environmental paperwork with your regulators if there's not a high level of trust. So I think the biggest thing that directed efficiency is We had the goal in mind from the very beginning. DOE, when they gave us this contract, said, your target is to clean up all the waste sites. We'll fund it. You guys do all of it. Okay, so we've had to work with the regulators, and early on we started defining what the finish line was so that we didn't go to false summits, that we went to the same finish line each time. And we worked very closely with these guys to make sure that we do that.
Where these contracts work the best, we call them performance-based contracts, is where the scope of work is very well defined. And then the contractors can go execute it. And in this case, it was well defined. They brought in a workforce that knew how to do the work. And again, in those situations, it works wonderfully. And Scott said something about cutting corners. I can tell you, when this was first let, EPA was very nervous because, again, the contractor, the faster they go, the more profit they make. So we geared up extensively to be out for oversight. We geared up for sampling, and it turned out they didn't cut corners. They did the job correctly.
Will your work be completed at the end of September 2015? And if not, why not?
So the bulk of our work will be finished at the end of 2015. 3 years ago, during the sequestration part of the federal budget, we had $477 million deferred out of our budget and our scope. And so because of that, 3 of our major projects were deferred beyond the end of September 2015. Those 3 projects were 61810, 61811 Barrel Grounds, and the 324 facility. So we've been working on all of those projects as we've been going on, but they're not going to be finished at the end of 2015. So currently we're working with the Department of Energy on what part of that work we will do, and how that'll be disposed of or dispositioned in the future.
Good morning, Jim Beaver, Benton County. How is it that you stayed ahead of schedule and saved money given the enormous challenges that you had to face?
We work hard. No, I think that answer is really simple. We have a very creative and hardworking workforce, and because we give them the target to go finish and they have all the work to do, they have the flexibility to execute that work. We have an extremely efficient workforce. They're incentivized to be efficient, and they're aggressive. And one of the things that makes me most proud about our project is when one of my guys says, "Can't we just go to work?" Okay, and we work hard and diligently on keeping going through that. We also talked about identifying and working with our regulators to make sure that we're not redoing work, overdoing work, or underdoing work, but we're aiming at the right target and we're hitting it every time.
Karen Lutz with the Department of Energy, but also a resident of the city of Kennewick. So this is for Nina and Dennis. As a regulator, but also as a citizen, or as a member of this community, how satisfied are you with the cleanup along the Columbia River? And what do you perceive as the biggest accomplishment that Washington Closure has achieved?
So I also am a resident of the Tri-Cities, and I raised both my daughters here. I am really impressed with the job that has been done for protecting the Columbia River, especially with the removal of the chromium.
Yeah, so in regard to the cleanup along the river, I'm extremely satisfied with where we landed. And it was pretty interesting because always one of the big questions to ask is how clean is clean? And I think in the case of the river corridor, we can say when the cleanup's done, it's going to be very clean. The goal of the cleanup was to allow any future use, and I think we've accomplished that goal. It'll be up to the Department of Energy and the community to decide what the ultimate use is out there. But again, we think we've done a job that will allow pretty much any use.
Scott, this was a very complex project, and I'm wondering what some of the surprises were. Dennis has just mentioned spent fuel, but can you share any other challenges that you had to deal with in order to get to the finish line?
Well, as you can imagine, when you're digging into barrel ground, you have no idea what you're going to find in that barrel ground. When we were making plutonium and in the initial throes of research and development, we didn't know, and a lot of times people will say because we're cleaning it up they didn't know what they're doing. That's absolutely wrong. Some of the smartest people in the entire world were working on this job in the 50s and the 60s and the 70s. And so, but the waste wasn't the thing that they were concerned about. The product was making plutonium and doing the things that they were trying to do. So the burial ground was just like any farm or ranch, you know, putting the stuff in there that they didn't need. Okay, and dispose of very highly radioactive stuff. So we found a lot of interesting stuff. I guess a few things that were interesting and fun. We didn't expect to have to dig 85 feet deep. Those holes are huge when you try to do that, and chase chrome all the way down. That was a surprise. Some of the interesting stuff that we find is we'll find a glove box that's buried in a burial ground, more barrels. The history of the stuff in the waste, and each one of those constituents, whether it's chemical or radioactive, we have to sample and chase. One thing I thought personally was really interesting is we were digging up one of our burial grounds outside the 300 area, and we found a safe. So our workers using the big, heavy equipment said, "I wonder what's in that safe." You know, and so you're thinking, well, what do you put in a safe, right? Money, gold. It's exciting. Well, what could be in this treasure in the safe? What we found was vials of plutonium. We didn't expect that. Okay. So while we're trying to dispose of these vials of plutonium, we asked the obvious question: where'd they come from? What are they? They were part of the very first batch of plutonium that was manufactured at Hanford, and our scientists, our PhDs, the guys that are interested in plutonium, were ecstatic. Okay, this is so cool because we can measure and check a lot of the things that they've been studying and theorizing over the last 60 or 70 years. And so they immediately wanted those plutonium. So we went from to clean up and dispose to restore and save and transfer properly to the PNNL, the national lab, so that they could study this. That was an interesting thing.
One of the things that WCH has done very well is the protection of some of the natural resources. In the 100D area, we have an area we call the bat caves. It's inhabited by a maternal colony of bats, but it also had pipes running through it that were a waste site. And working with WCH, they preserved access to those tunnels for the bats, and then also have been able to disposition the pipes by leaving them in place, but leaving them fairly protective, so they're protective of the human health and the environment, but also protective of the bat caves.
Hi there. I've read about some of the big digs in the 100D area. Can you talk about what the big digs are?
Well, we've touched on what the big digs in the D area are. We had 3 very large big digs. One was in the BC area, and 2 were in the 100D area. Each one of those was chasing chrome plumes. Chromium gets drugged through the dirt by water. Okay, so you can imagine that it's just a vein of chrome that goes down through, and our excavators can actually see the chrome in the dirt. They can't see it to the cleanup standards, but they can see where the bulk of the chrome is, and we clean around that. So when we started digging into those big digs start with, you think 85 feet deep, that doesn't sound too bad, okay? But to get to 85 feet in the bottom, it's got to be several hundred yards across at the top. Okay, so the slope has to be safe so it doesn't collapse on the workers that are inside it. We're driving very big and very heavy equipment down roads into the bottom of these holes, so essentially they're large mines. So that's what the big digs are.
I have to say, having gone out and seen the big digs in the 100D area, that they are immense. But yet, at the bottom of it, at times you could still see the greenish deposits from the chromium. I'll add one note is that the 100 area is really winding down, especially with cleanup of the soil. Groundwater's cleanup's going to continue for a while. Now the focus will turn to the 200 area, and I'm excited to see the expertise be transferred up onto the plateau and hope that that will begin remediation in the very near future.
To find out how you can become more involved in this important regional issue, or to have a Hanford Communities speaker talk to your organization, contact the Hanford Communities at 509-942-7348 or by fax at 509-942-7379, or visit our website at www.ci.richland.wa.us.